Okay guys, so this is the Unit 4 review booklet. We're going to look at the first few questions. So number 1 here says the image below shows a pattern of sections made of fence from boards. Complete the following table. So if you look at the first image, there are 4 fence boards and it makes a perfect square here. Then if you look at the next image, there are 1, 2, 3, 4, 5, 6, 7 fence boards. So the third one we have to complete the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fence boards. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 fence boards. So how do we complete the rest of this table? Well, if you just look, you could draw the next section if you wanted to, or if you just look at the pattern, we're going up by 3 each time. So 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16. So that kind of answers our B part here. How many boards are added for each new section? 3 boards are added. And then if the same number of boards have been added to each section of fence, how many boards would the fence 0 theoretically have? So if we're going to look, fence 1 has 4 boards. So if we go backwards 1 step, to figure out what fence 0 would have. Well, when we travel backwards, instead of adding 3, we're doing the opposite. We're subtracting 3. So 16 take away 3 is 13, 13 take away 3 is 10, so on and so forth. So we can say 4 take away 3 would be 1. So the fence 0 would have 1 board. Okay? And then write an equation to represent the relation. So there's a number of different ways we can do this. I'm just going to mark these so we know they're the new answers. There's a number of different ways we can do that. One option is to figure out that we're going up by 3 each time, and then just using the values there, determine what we add. We know our equation is going to be the number of boards equals, because we increase by 3 each time, it's going to be 3 times the number of fencing, but what do we add? So we can use the values we already have to help determine that. So when it was 1 fence, 1 times 3 plus what will give us 4. 2 times 3 plus what will give us 7. Or we can just look way up at C and the 0 fence value. The 0 value is what we're going to add each time. So because the 0 fence would have 1 board, we'll say B plus 3F, or B equals 3F plus 1 would be our equation here. Okay. So let's look at the next example. We have a pattern here. And there is a mistake in this one. The first diagram has 4 hexagons. The second one only has 5, not 7 hexagons. So you can go ahead and fix that. The third one has 6 hexagons. The fourth one has 7 hexagons. And if we follow this pattern of adding 1 each time, the fifth one would have 8 hexagons. So every time the figure increases by 1, the number of hexagons increases by how many? Increases by 1. So we had 4 hexagons, then 5, then 6, then 7. So how many hexagons would the 0 figure have? Well, if the 1 figure had 4, to go back 1, the 0 figure would have 3 hexagons. So write the equation. So because we're increasing by 1 each time, it would be the number of hexagons equals 1 times the figure number, because we increase by 1 each time, plus 3, which is our 0 figure. So the numbers in B and C give us the numbers we need for our equation. What are we increasing by each time? That's the coefficient to our variable. So that's the number that goes out in front of the F. And what is the 0 figure? That's the number being added to the F. Okay, let's look at another one. Consider the following pattern made with toothpicks. So the first image has 4 toothpicks, and then 8, and then 12. How many would the next one have? So if we look, we're increasing by 4 each time. So 12 plus 4 would be 16. 16 plus 4 would be 20. And then we jump up to 10. So in order to do that, before I fill in 10, I'm actually going to write the equation first. That'll help me. So the number of toothpicks equals, because we're increasing by 4 each time, 4 will be my coefficient. And what would my 0 value be? So if the 1 value is 4, to go backwards, we would have to go back 4, which would be 0. So we don't need that plus 0, so it would just be 4f. So 4 times the figure number will give us the number of toothpicks. So if the figure number is 10, well, 4 times 10 is 40. Okay, so be careful of that. There is a jump there in the figure number, so don't just keep going up by 4 each time. Be aware of the figure number there. This one does the same thing. So if we look at this pattern, the first figure has 1 square, the second figure is 3, and then 5. So you can see that we're increasing by 2 each time. So the fourth figure would have, if you can count there, 7. The next figure, which isn't drawn, you can draw it if you want to, if you feel like it would be easier, is 9. But we don't know the 10th figure. But let's write the equation first because it makes life easier. So the number of squares equals, so because we're increasing by 2 each time, it would be 2 times the figure number plus, what would that 0 value be? So if the 1 value is 1, we're increasing by 2 each time, so to go backwards, we would have to subtract 2. So 1 take away 2 is -1. So you could say 2f plus a -1, or you could just say 2f minus 1. That would be fine. So then what would the 10th value be? Well, you would do 2 times 10 minus 1, right? 2 times 10 minus 1, because we just plug in 10 for the figure number. So 2 times 10 would be 20, and 20 minus 1 would be 19. So the 10th figure would have 19 squares. Okay. So then it's the same type of question, but we don't have a pattern to look at anymore. We're just going right to the table, but that's fine because we really don't need the pattern. So here my x value, my independent variable is going up by 1. My dependent variable, 4, 8, 12, I can see it's increasing by 4. So 12 plus 4 would be 16. 16 plus 4 would be 20, and 20 plus 4 would be 24. So what is my equation going to look at? Well, right away I see I'm increasing by 4. That tells me the coefficient, the number that's going to be out in front of the x, has to start with 4. Right? So right away I see that this is the only equation where the coefficient to the x, or the number out in front of the x, is 4. So that would have to be the option. You can double check. There's no value being added to the x. So let's explore. Remember that value being added to the x is the 0 value. So if the 1 value is 4, and we're increasing by 4 each time, to backtrack, we'd have to subtract 4. 4 take away 4 is 0. So this, you could write this something like that, 4x plus 0, but you really don't need to. Okay. Okay, number 6. So my independent variable, my x values, is going up by 1 each time. My dependent variable is going 8, 9, 10, so it's also going up by 1 each time. So 11, 12, 13. So which value, which expression would represent the pattern? Well, the coefficient to the x, the value in front of the x, would have to be 1, because my y value is increasing by 1 each time. And the first 3 equations, the x all have a coefficient of 2. So that means that this last one, x plus 5 equals y, must be the answer. Let's double check that plus 5 to make sure we're on the right track. So when x is 3, y is 8. Then when x is 2, y would have to be 7. When x is 1, y would have to be 6. So when x is 0, y would have to be 5. So that makes sense, x plus 5. Okay, so we're going to continue on. We're just going to do 2 more problems today. So consider the following table of values. So this time you're given the table of values, but we're going to solve the same types of questions we've been doing before. How much does the dependent variable increase each time? So the dependent variable is always the variable in the right column. In this case, it's the number. And we have 2, 3, 4, 5, 6. So it increases by 1 each time. What would the 0 term be? So if it's increasing by 1 each time, and the first term is 2, then the 0 term, we would just have to go back 1 or subtract 1. So the 0 term would be 2 take away 1, which is 1. So what would the expression be? So we do, we'll say n for number equals, so we say, what does it go up by each time? It goes up by 1 times the term, which we'll say t, plus the 0 term, which is 1. Okay, so we're using the values from A and B. What is the increase or decrease? That's what's being multiplied by the t, and the 0 term is what's being added to the t. And the last one we'll do is the same type of question. How much does the independent variable increase by each time? So it goes 1, 3, 5, 7, 9. So it increases by 2 each time. What would the 0 term be? So it's going up by 2 each time. The 1 term is 1, so we'd have to subtract 2 to go backwards. The 0 term would be 1 take away 2, which is -1. So what would the equation be? We would say n for number equals, because we're increasing by 2 each time, it would be 2 times the term, and then we could say plus a -1 or -1. So we'll stop there for now, and then check out the next video where we'll continue on with number 9.